Imagine for a second, right, that you are at your kid's birthday party.
Oh, yeah, the classic scenario.
Exactly. The cake is out, the candles are lit, and you raise your phone to take that one perfect photo.
Right.
You snap the picture, but right as the shutter clicks, your kid just, looks entirely away.
And historically, I mean, that was just it. The
Uh,
photo was ruined, the moment was lost, and you just had to live with it.
yeah, you just delete it or keep a bad photo. But today, well, we're looking at a new Apple technology that lets you literally twist the spatial perspective of the camera, like after the photo is already taken.
Which is just wild. It's using artificial intelligence to essentially hallucinate the missing reality
Yeah.
and force the subjects to look perfectly at the lens.
Unbelievable.
It fundamentally changes our relationship with digital memory, you know? I mean,
Yeah.
we're moving from capturing reality to actively curating it down to the exact angle of a person's gaze. It really is a huge shift. Well, welcome to the Deep Dive. Today, we are taking you through the massive wave of announcements from Apple's Worldwide Developers Conference, WWDC 2026.
And there's a lot to cover.
Oh, so much. Our mission here is to unpack all of this, and we're relying directly on the official keynote transcript and Apple's comprehensive press release to figure out exactly what happened.
Because, while everyone right now is buzzing about AI, Apple's event actually told a very specific, carefully constructed three-part story.
Right. They didn't just jump straight to the flashy AI stuff.
Exactly. They started by optimizing the foundational experience of the operating systems. Then second, they built incredibly robust safety guardrails for families.
And then, only after those two things were firmly established, did they unleash this radically new suite of tools they're calling Apple Intelligence.
That progression is entirely deliberate. I mean, before you can build a towering skyscraper of AI features, you have to reinforce the concrete foundation.
Makes total sense. You can't just slap a massive language model onto an operating system that's, like, stuttering or dropping Wi-Fi connections or draining your battery.
Right. The plumbing has to work.
Which brings us to the surprisingly deep system-level optimizations Apple announced first. They spent an unusual amount of time talking about that plumbing.
Okay, so let's unpack this plumbing. We are looking at the foundation of OS 27. So this covers iOS 27, iPadOS 27, macOS 27, watchOS 27, visionOS 27, and tvOS 27.
That is a mouthful.
It really is. Apple is clearly sweating the details here. But before we get into the technical architecture, I have to bring up the macOS naming moment because, it's a WWDC tradition.
Oh, it is the requisite moment of levity before they dive deep into the code.
Right. So in the keynote, Craig Federighi did his usual running joke about Apple's crack marketing team coming up with the name for the new macOS.
Right, the yurt.
Yes. Apparently, they spent time in a newly installed Apple Park experiential ideation yurt, piled into an electric microbus, and handed him a note about their chakra alignment.
Setting their compass to the summer of love.
Right. Yeah, floating on a span of gold over infinite seas. Ultimately, Greg Joswiak had to step in and decode the hippie poetry, and the new name is Mako Golden Gate.
It's a fun bit of theater, but it actually serves as a surprisingly effective transition into the design refinements they are bringing to macOS, Golden Gate, and really across all the platforms.
Yeah, they are focusing heavily on the visual language they introduced last year, which they called Liquid Glass.
Let's talk about Liquid Glass. This was their big cross-platform design update. It made apps and menus look translucent, almost like they were made of actual glass, refracting the content behind them.
But if you remember the user feedback from last year, it wasn't universally loved.
No, it definitely wasn't.
Some people found the translucency really distracting. Like if you had a really busy wallpaper, suddenly your Finder windows were incredibly hard to read.
And that is exactly where the refinements come in.
Yeah.
You know, when you introduce a bold design aesthetic like Liquid Glass, you are asking the graphics processing unit, the GPU, to do a lot of real-time rendering.
Right, it's constantly calculating.
Exactly. Calculating light refraction and blurring effects as you drag windows around. But beyond the computational cost, there's the cognitive cost to the user.
Yeah, because we don't all process visual information the exact same way.
Exactly. What is beautiful to one person is an absolute accessibility nightmare for another. So, Apple analyzed this and tuned Liquid Glass to diffuse complex content behind it more effectively, creating more depth and separation for readability.
But they didn't stop at just a one-size-fits-all system-wide adjustment. They introduced a slider.
Which is huge.
It is. In the display settings, you can now adjust the liquid glass effect manually. If you want it ultra clear and refractive, you can leave it there.
But if you suffer from eye strain,
Yeah.
or you just prefer a fully tinted, opaque, classic Makos look, you can slide it all the way over.
And they've engineered this so that developers who already adopted the Liquid Glass APIs, well, they'll have these user customizations apply to their third-party apps immediately without writing a single line of new code.
Analyzing why Apple is doing this is crucial, I think. It's about giving users agency over their visual environment.
Right.
But simultaneously, Apple is aggressively unifying the structural layout across all their platforms. On the Mac, we are seeing uniform toolbars across the top of apps to keep text labels legible while providing rigid structure.
And those sidebars now expand to the very edges of the window.
Yeah, they've removed the bezels and borders to reduce visual noise, delivering those same refractions as content scrolls underneath.
And okay, the sidebar icons got their color back. I know that sounds like a minor detail.
No, but it's not.
No, it really isn't. When you have 6 windows open, color coding makes it exponentially easier to tell which window is active in the foreground at a glance.
Plus, they enforce tighter, consistent corner radiuses on every single window on macOS, even if the app hasn't been updated in years.
They even redesigned the app icons themselves, baking layers of liquid glass directly into the icon artwork to make them look sharper and more defined, whether they are sitting in your dock or on your iPhone home screen.
And this uniformity, it isn't just about making things look pretty, it's entirely functional.
How so?
Well, think about the hardware ecosystem. When you are moving from an iPhone in your pocket to a Mac on your desk to an iPad on the couch, and increasingly to an Apple Vision Pro headset strapped to your face, the visual language needs to feel completely native everywhere.
Ah, I see.
The liquid glass aesthetic, with its layers and refractions, is perfectly suited for spatial computing in Vision OS. By pulling that exact same layered, refractive look down into the standard two-dimensional operating systems, it essentially trains the user.
So it makes the eventual transition between physical glass screens and spatial computing environments feel completely intuitive.
Exactly. You're building muscle memory across devices.
That makes a lot of sense. But, a beautiful, visually cohesive house doesn't mean much if the plumbing is backed up.
Right.
Let's talk about the under-the-hood performance, because the engineering team threw out some numbers that demand closer inspection.
The performance metrics they highlighted for OS 27 represent a massive, coordinated effort across multiple engineering teams. They scoured the operating system layer by layer for opportunities to refine memory usage, CPU utilization, display rendering, and network handshakes.
Right. For instance, they stated that iPhone and iPad apps will launch up to 30% faster.
30%.
30%. I mean, in software engineering, gaining a 30% speed bump without changing the physical silicon processor is massive.
It's huge. And the mechanism they are using to achieve this is really clever. The OS now utilizes predictive resource management.
How does that work?
Basically, it preloads the key data that apps need into the active memory when it anticipates you're going to open them. So they are essentially fully loaded before your finger even touches the icon.
So it's essentially memory paging on steroids.
Exactly, and it extends across the entire system. Because the file system has been optimized, new high-resolution photos you take will parse and load into your library up to 70% faster.
Oh, yeah.
When you use AirDrop to send large video files to a friend, the network protocol has been streamlined, so those transfers are up to 80% faster.
And for the power users, browsing files and transferring them from an iPad to a physical external drive is up to 5 times faster, which finally makes the iPad's file management as robust and speedy as using the Finder on a Mac. Okay, but here is the technical detail that I really want to dig into. They talked extensively about the CPU scheduler.
Oh, yeah. This is fascinating.
For you listening, the CPU scheduler is the system component that manages all the computing resources as you use your phone.
Think of it like the conductor of the orchestra.
Exactly, making sure the right thread of work is executed by the processor at the exact right millisecond, especially when you are jumping between like a game, a text message, and a video call.
Modern processors have different types of cores, right? You have performance cores for heavy lifting and efficiency cores for background tasks.
Right.
The scheduler decides which core gets which task. If the scheduler is inefficient, your battery drains and the phone feels jittery.
Right. Now, iOS already had a highly advanced CPU scheduler on the newer iPhones like the 14 and 15, and they optimized it further this year. But then they announced they figured out a way to backport this modern, highly complex CPU scheduler all the way back to the iPhone 11.
Which is honestly incredible.
To put that in perspective, the iPhone 11 was released in 2019 running the A13 Bionic chip. It's like rewriting the foundational flight logic of a state-of-the-art air traffic control system, optimizing it perfectly, and then successfully installing it into an airport built almost a decade ago.
That's a great analogy.
You don't need to build new runways to make the planes fly smoother. You just route the computational threads with modern mathematical efficiency. And because of this architectural feat, iOS 27 is supported on the exact same devices as iOS 26.
That is a remarkable feat of software engineering. Extending the lifespan of older devices by retrofitting modern core management systems is exceptionally rare in this industry.
Yeah, why is that?
Primarily because it is incredibly difficult and, frankly, offers no immediate financial return. However, it speaks to a strategic commitment to the entire install base. Apple needs developers to adopt new APIs, and developers only do that if the majority of users are on the latest OS.
Ah, I see.
So making the OS run flawlessly on a 5-year-old phone ensures high adoption rates.
That's really smart. And they are also fixing those little daily friction points that drive us all crazy, the things that aren't glamorous but affect every single user.
Search, for instance.
Yes. They completely rebuilt the foundation of the semantic search index that powers Spotlight, Photos, and Mail across all the platforms.
The search index is essentially the massive invisible catalog your device continuously builds of all your text, images, and metadata.
They re-architected it so it operates more cleanly in the background. As new content comes in, it's indexed almost immediately without slowing down the phone.
Mail even gets a completely new algorithmic ranking system to surface relevant results in your top hits based on your past interactions, even if the email you're looking for is buried months deep.
They also spent significant time addressing network transitions. I mean, we've all experienced what we can universally call the coffee shop Wi-Fi trap.
Oh, it is the absolute worst.
It really is.
Yeah.
You're walking down the street listening to a deep dive or on an important voice call, and your phone desperately tries to cling to the incredibly weak one-bar Wi-Fi signal of a coffee shop you walked past 3 blocks ago.
And it just refuses to let go.
Right, completely dropping your data connection until you manually swipe down into the control center and violently turn Wi-Fi off.
Precisely. That happens because, traditionally, devices prioritize Wi-Fi over cellular data to save the user money and battery. But Apple has now fundamentally rewritten the network handshake logic.
So what does the iPhone do now?
It is now actively analyzing the ping latency and packet loss of the Wi-Fi connection in real time. It's smarter about when to intentionally drop a degrading Wi-Fi signal and switch seamlessly to the cellular network to avoid that exact dead zone scenario.
That is such a relief.
Furthermore, if you are in a low bandwidth situation trying to send a massive 4K video in Bragg, messages won't freeze up your entire conversation queue anymore. You'll get a new granular send indicator for each specific message payload, showing you exactly what packet has and hasn't been delivered.
It's basically a comprehensive war on friction.
It really is.
Now, thinking about the fact that they brought this incredibly smooth, fully updated OS 27 back to older devices like the iPhone 11,
Right.
that brings up a really crucial demographic reality. Those older devices, the iPhone 11s, the iPhone 12s, those are the exact phones that usually get handed down to kids.
Exactly.
Which sets up the next massive chapter of this keynote perfectly. Apple's complete overhaul of the family digital ecosystem and safety boundaries.
This was a deeply detailed portion of the event, and it really represents a philosophical pivot.
How so?
For years, Apple, like most tech companies, relied on passive tracking tools. They give a screen time, which essentially just showed parents a bar chart of how much time their child spent on TikTok or Minecraft.
Right. It was informative, but entirely passive.
Now they are shifting toward an active, research-backed management architecture that is built into the core logic of the operating system.
And that fundamental shift begins the absolute second you pull the phone out of the box.
Yes, the setup process.
If you are setting up a phone for a child, the setup assistant has been entirely redesigned.
Yeah.
The absolute first step they are emphasizing in bold text is creating a dedicated child account.
And the moment you designate the user as a child, the OS immediately alters its security posture. It establishes a default deny perimeter.
It automatically blocks adult websites at the DNS level, right?
Yes. It restricts age-inappropriate media in Apple Music and TV and locks down the App Store so nothing can be downloaded without authentication.
And for parents whose kids are currently using standard accounts, they've built a migration tool to easily convert an existing account into a lockdown child account without losing the child's photos or data.
The philosophy here is about establishing a secure, impenetrable perimeter before the device is even handed over to the minor. From that secure baseline, Apple introduces highly granular control over what gets permitted inside the wall. Parents use the Setup Assistant to systematically choose exactly which third-party apps they want to allow.
So they can choose a handful of essential communication apps, a bundle recommended by child psychologists, or curate a highly specific app-by-app whitelist.
Exactly. We're already intimately familiar with the Ask to Buy feature on the App Store. A kid tries to download a new game, and the parent gets a rich notification in messages asking them to approve or deny the transaction with Face ID.
But now Apple is extending that exact same mechanism out into the wild west of the internet with a feature called Ask to Browse.
This is a huge deal.
If a child attempts to navigate to a new, unapproved website domain in Safari, they just hit a wall. They have to tap a button to request permission.
And then the parent receives a notification. They can preview the website to see what it is, and then approve or deny access.
And because of the underlying iCloud architecture, this syncs seamlessly. A kid can ask to browse on their iPad, and the parent can approve it from their Mac at the office.
This strict gatekeeping is turned on by default for any child under 13, and parents have the option to toggle it on for teenagers.
But, controlling access to new content is only one pillar of the strategy. Managing the duration of time spent on that permitted content is the other, far more contentious pillar.
And this is where Apple's new partnership with the American Academy of Pediatrics, the AAP, becomes incredibly significant from a structural standpoint.
Right. Apple is taking the AAP's established family media plan, which has existed as a clinical document for years, and translating it into a software guide integrated right into the iOS settings menu.
They've introduced new time allowances.
When a parent opens the redesigned screen time dashboard, they are greeted with 3 main categories: entertainment, games, and social media.
And here is the crucial distinction that separates this from old software. Apple isn't just handing parents a blank, intimidating 24-hour timer and telling them to figure it out.
Right. For each of those specific categories, and for a total aggregate across all 3, Apple is providing a daily time allowance recommendation right on the screen as a default starting point.
And these algorithm recommendations are dynamically generated based on the child's exact age, and they were developed directly in consultation with clinical child development experts. I have to play devil's advocate and push back on this approach, though.
Okay, let's hear it.
Doesn't this risk making Apple the bad cop instead of the actual parent? Think about the family dynamic. A kid wants more time to play Roblox, and the parent says, well, the Apple algorithm says you only get an hour, take it up with Tim Cook.
Right.
Does that fundamentally outsource the responsibility of parenting to a multi-trillion-dollar tech corporation?
That is a very common and valid skepticism. However, behavioral psychologists argue that it actually empowers parents rather than undermining them.
How so?
One of the most exhausting aspects of navigating digital rules with children is that the rules often feel arbitrary to the child. Why do I only get 30 minutes of YouTube? Because I said so. Yeah, that invites endless negotiation and conflict.
Exactly. By providing a clinically recommended baseline right in the interface, Apple is giving parents an objective, expert-backed standard to point to. It grounds the family discussion in documented health research rather than just parental whim.
So it shifts the conversation from mom's being mean to this is what doctors recommend for your developing brain.
Precisely. And importantly, Apple's interface makes it abundantly clear that every child's needs are unique. Parents maintain ultimate administrative control and can effortlessly adjust those suggested allowances up or down based on what is best for their specific family dynamics.
And it's not just a flat, rigid daily timer anymore either. They've introduced contextual schedules,
Which is incredibly helpful.
A Tuesday during the school year requires an entirely different digital posture than a Saturday in July. So now, a parent can set a granular schedule that actively locks down all distracting apps during school hours, say, from 8:30 a.m. to 3:00 p.m.
During that window, the device is transformed. It can only be used for approved educational tools or emergency phone calls.
And this scheduling system works hand in hand with the time allowances, so you can easily offer an extra 2 hours for a movie night on a weekend without having to go into the settings and blow up the entire weekly restriction architecture.
Beyond just time management, Apple has significantly escalated their intervention in communication safety. We know that Apple previously introduced opt-in features to use on-device machine learning to blur nudity in messages and FaceTime for minors.
Right.
This year, they're expanding the scope of that visual intervention to actively blur and block gore or violently graphic content in shared images or videos before a child's eyes even process it.
And parents retain absolute control over the social graph. They can dictate exactly who a child is allowed to text or call, starting with a baseline of just immediate family and explicitly requiring parental approval to add any new contact to the address book.
But here is the most fascinating architectural change. Apple is finally pushing a massive share of this safety responsibility onto the third-party app developers themselves.
Yeah, they've handed developers a full suite of new tools, the most significant being what they call the Declared Age Range API.
This specific API is a masterclass in balancing child safety with strict cryptographic privacy. In the past, if a developer wanted to know if a user was a child, they either had to ask the child to type in their birth date,
Which kids lie about constantly.
exactly, or they had to hoover up vast amounts of behavioral data to profile them, which violates privacy laws.
Right.
The Declared Age Range API solves this in a completely privacy-preserving manner using zero-knowledge proofs. An app can query the operating system for the user's age range.
Explain how that works technically. How does the app know the age without knowing who the kid is?
Okay, so when a child opens a game or a social platform, the app sends a secure ping to iOS. iOS checks the iCloud account, verifies the cryptographic token representing the age bracket, say 10 to 12 years old, and hands that generic bracket back to the app.
So the app never gets the child's name, exact birth date, or Apple ID.
Exactly. It just gets a verified, unscoopable badge that says this user is a preteen.
Wow.
With that verified data, the developer is now mandated by Apple's App Store guidelines to automatically tailor the experience natively. They must shield inappropriate content, disable predatory microtransactions, or prompt their own in-app parental controls without the parent having to configure the app manually.
Okay, so let's summarize the board state. They've ruthlessly optimized the operating system foundation so it runs incredibly fast, even on 5-year-old chips. They've built these incredibly robust, cryptographically locked-down safe spaces for kids. Why spend the first third of a developer keynote meticulously laying out all this plumbing and family security?
Because establishing absolute control is the prerequisite for unleashing chaos.
Unleashing chaos, I love that.
Creating these safe, walled gardens and proving that they can restrict computing environments is exactly what gives Apple the institutional confidence to deploy its most powerful, unconstrained, and potentially unpredictable technology yet for the adult user base.
You cannot safely introduce a highly capable generative artificial intelligence system universally across a billion devices without first ensuring you have an airtight mechanism for controlling who gets to use it and how it behaves when it hits edge cases.
Exactly.
Which brings us to the absolute core of the WWDC announcements, the brain of the operation, the introduction of Apple Intelligence and the bombshell partnership with Google Gemini.
This is the moment the keynote fundamentally shifted gears from evolution to revolution. Craig Federighi took the stage and started by drawing a very sharp, very intentional contrast with the rest of the tech industry.
He noted that over the past 2 years, other companies have been caught in a frantic arms race, seemingly pursuing AI capabilities for the sheer sake of AI.
Often deploying experimental models without clear regard for the people meant to use them or the privacy implications involved.
Apple's stated vision is dramatically different. They argue that for AI to be truly helpful, it must be centered entirely around the user, integrated deep into the core architecture of daily products rather than siloed in a chatbot app.
Grounded deeply in personal context, and above all else, designed from the silicon up with absolute privacy.
Right, and the umbrella term for this entire next-generation architecture is Apple Intelligence. At the bedrock of this are the newly developed Apple Foundation models. These are models trained specifically by Apple.
Then, they dropped the news that stunned the industry. Apple has entered into a deep structural collaboration with Google, leveraging the massive server-side technologies behind Google's Gemini family of models to augment Apple Intelligence.
I have to stop you right there. When I read this in the keynote transcript, I was completely incredulous.
Most people were.
Let's talk about the history here. Apple is the absolute king of the walled garden. This is the company that literally bought multi-story billboards in major cities with slogans mocking Android and Google's data harvesting practices. Tim Cook has given speeches lambasting companies that treat users as the product. Now, Apple is integrating Google's core AI models into the very heartbeat of iOS. Explain to me how that isn't a massive hypocritical surrender and how it possibly works with Apple's obsession with privacy.
It is undeniably the ultimate strange bedfellows scenario in modern tech history. But if you pull back the curtain on the technical architecture they've engineered, it explains exactly how they pull this off without compromising their stated morals.
Oh.
It all comes down to a strictly enforced, tiered processing system. First, Apple has heavily adapted their own new foundation models to run exclusively on device.
Okay.
This means for the vast majority of your daily tasks, understanding text messages, generating natural-sounding speech, basic image processing, summarizing emails, the artificial intelligence runs entirely locally on the Apple Silicon Neural Engine physically located inside your iPhone or Mac.
So your personal data never leaves the hardware in your hand. That makes sense. Local processing is inherently private, but on-device processing has rigid physical limits. You simply cannot fit the multi-trillion parameter computing power of a massive liquid-cooled server farm into a piece of glass that fits in your pocket.
Exactly. The local hardware eventually hits a ceiling when faced with complex reasoning tasks. And that is precisely where their new architecture of private cloud compute comes in.
What is private cloud compute?
When Siri or an app determines that a user's request is too complex for the local processor to handle, say, analyzing a massive spreadsheet or generating a complex spatial rendering, it needs server power.
Right.
But instead of just blindly pinging a standard data harvesting Google server via an API, Apple has created a cryptographically secure, isolated cloud environment.
So the mechanics of private cloud compute are what justify the Google partnership.
Yes.
Apple takes your complex request, anonymizes it, and routes it to specialized servers built with custom Apple silicon. What's crucial here is that the software running on these servers is cryptographically locked.
The data you send is never stored on a hard drive, it is never used to train anyone's models, and it is mathematically inaccessible to Apple, to Google, or to any government entity.
The data exists in the server's RAM only for the exact milliseconds required to execute your specific request. The answer is calculated, sent back to your phone, and then the server's memory is instantly wiped clean.
And Apple took the unprecedented step of stating that independent cybersecurity experts and academic researchers can continuously inspect and verify the software code running on these private cloud compute servers.
To ensure these privacy promises are mathematically sound.
Exactly. So to answer your earlier question, they are attempting to have their cake and eat it too. They are tapping into the massive reasoning capabilities of Google Gemini for complex queries, but they're doing it through a heavily armored proxy tunnel that maintains absolute privacy.
The operating system acts as a seamless orchestrator, instantly deciding, can I process this locally? Yes. Okay, this next request needs more juice. Encrypt it and send it to the secure private cloud compute. The user just gets the answer.
This hybrid architecture, combining lightning-fast, secure on-device models with strictly segregated, hyper-powerful private server models, is what unlocks the headline feature of the entire event.
The complete ground-up rebirth of Siri.
It's hard to overstate how significant this is. Siri is no longer just a basic voice assistant that sets timers and tells bad jokes. It has been fundamentally transformed into an intelligent, knowledgeable, and highly capable entity.
And it is now deeply structurally integrated into every platform: iPhone, iPad, Mac, Apple Watch, and Vision Pro.
Let's explore the capabilities of this new Siri AI, because they are vast. First and foremost, it finally has deep personal context understanding.
Which ties back to the semantic search index we were talking about.
Exactly. It plugs directly into that rebuilt semantic index. Siri now has access to the metadata of your life. You can casually ask it, hey, pull up that photo of me and Sarah from the hiking trip a few years ago. Or find that PDF with the quarterly projections.
And it instantaneously searches across your messages, your buried emails, your hidden files, and your photos to find the exact asset.
It also has what Apple calls on-screen awareness. It actively understands the visual context of what app you are looking at in that specific moment.
And crucially, with a new framework called App Actions, Siri can reach its digital hands into your apps and use their native tools to complete a request, like drafting an email, applying a filter to a photo, or moving a file.
And perhaps most importantly for daily use, it is finally truly conversational. The LLM underlying Siri allows it to maintain a rolling context window.
The keynote showcased a brilliant example of this.
Oh, the concert example.
Yes. A user asks Siri about a Suki Waterhouse concert in San Francisco. Siri uses its broad world knowledge powered by the cloud to find the date, July 26th.
The user then asks how to get tickets, and Siri explains there's a lottery system.
And the user doesn't have to repeat the artist or the venue. They just say, remind me to sign up when the lottery opens, and Siri sets the precise reminder.
Then the user says, now let's hear one of her new singles. and Siri instantly starts playing the music. It seamlessly held the abstract concept of Suki Waterhouse and the concert through an entire back-and-forth dialogue involving 3 different apps.
It also handles human error gracefully now. In another demo on the Mac, a user was asking Siri to compare quotes from different contractors for building a shed maker space.
Right, and they typed it really fast.
Yes, the user hastily typed, "Luke mentioned an electrical problem," completely misspelling the word electrical. Old Siri would have failed or searched the web for the misspelled word.
But Siri AI seamlessly understood the semantic intent, recognized the typo, searched across months of iMessages and emails to find what the user's son, Luke, had previously shared about a specific wiring issue, synthesized that information, and used it to recommend the contractor best suited for electrical work.
Because of these vastly expanded capabilities, the interface itself had to evolve. On iOS, you can still trigger it by saying, "Hey Siri," but you can also swipe down from the dynamic island to bring up a keyboard and start a silent conversation by typing.
The interface is fluid, glowing around the edges of the screen rather than taking over the whole display. And because these conversations are now so rich and multi-layered, Apple recognized the need for persistence, so they created a brand new, dedicated Siri app.
This is a major structural shift. Siri is no longer just an ephemeral voice overlay that vanishes into the ether the second you swipe away. It is a physical home on your device.
The Siri app provides a visual, searchable overview of your entire conversational history. And because of the underlying iCloud architecture, this history is synced privately across all your devices.
So you can start planning a complex travel itinerary with Siri on your iPhone while commuting on the train, walk into your house, pick up your iPad, and that exact same conversational thread is waiting there for you to continue. You can then move to your Mac to finalize the bookings.
The physical manifestation of Siri goes even further on the Vision Pro.
Yeah.
In the spatial computing environment, Siri AI actually appears as an interactive 3D visualization that you can grab and place anywhere in your physical room.
You don't even have to use a wake word anymore. The Vision Pro's eye-tracking cameras know when you are looking directly at the Siri sphere, so you just make eye contact with it and start talking.
The voice synthesis experience has also been radically upgraded for devices equipped with the silicon necessary to run the most advanced on-device models. Siri sounds shockingly natural now.
They showcased a demo where Siri read a complex text message from Jaws about shipping apricots, and the vocal inflection, the natural pausing, the casual conversational tone, it sounded entirely human.
Users can even go into settings and deeply customize Siri's voice, adjusting parameters like expressivity, pitch, and speaking pace until it perfectly matches their preference.
And that sophisticated language processing ties directly into system-wide dictation, which received a massive boost in accuracy. Whether you are quickly texting on a noisy subway or dictating a long entry into a journaling app, the on-device AI handles complex spelling, contextual punctuation, and grammar dynamically.
But Siri AI isn't confined to just listening and speaking anymore. It has been given eyes. Apple introduced a suite of powerful capabilities under the umbrella of visual intelligence.
On the iPhone, this takes the form of a brand new, dedicated Siri mode integrated directly into the native camera app. You tap a glowing shutter button to let Siri temporarily see whatever is in front of the lens.
It processes that live video feed securely, bouncing it off the private cloud compute servers if necessary, to give you a highly contextual response and suggest immediate relevant actions.
The practical examples they demonstrated for this were straight out of a science fiction film.
They really were?
Imagine you point your iPhone camera at a complex plate of food, say a bowl of authentic pho.
The computer vision algorithms analyze the ingredients, cross-reference them with nutritional databases via the LLM, and Siri instantly provides an overlay with a breakdown of calories, macros, and nutritional insights.
Or you are at a restaurant with 3 friends, you point the camera at the itemized receipt on the table, you simply tap the items you ordered, and Siri calculates the tax and tip and automatically sets up an Apple Cash request to split the tab with the correct contacts in your phone.
On macOS, visual intelligence is accessed via a system-wide keyboard shortcut. You can drag a selection box over anything on your display, a graph, a photo, a block of code, type a specific question to Siri, and it will help you understand it or take action.
If you highlight a messy, unformatted schedule in a PDF document, Siri will parse the text, understand the dates and times, and suggest adding all of those events to your calendar with one click.
But the Vision Pro example they showed was the most profound demonstration of where this technology is heading.
Oh, the backpacked example.
Yes. Imagine you are wearing the headset, and you look at a backpack sitting on a table, specifically an REI Flash 22 pack. You ask Siri, will this work as a carry-on for my flight in September?
The system executes a highly complex chain of operations. First, the computer vision recognizes the specific make and model of the bag. Second, Siri queries your personal semantic index to find your upcoming flight itinerary to Iceland.
Third, it checks the specific airline's baggage dimension restrictions via the web. And finally, it confirms the bag will fit.
Then you look down at a pair of large Loa hiking boots on the floor and ask, will these physically fit inside? And Siri analyzes the 3D spatial dimensions of the boots using the headset's depth sensors, compares it to the internal volume of the bag, and tells you yes, but it will be a tight squeeze.
It's synthesizing real-time visual recognition, deep personal data retrieval, internet search, and complex spatial mathematics, all in the span of 2 seconds. It is a profound leap in everyday utility.
It is impressive, but talking to Siri is still an explicit active process. You have to initiate the request. The real breakthrough in these sources isn't just what Siri can say or see when prompted. It's what the AI can actually do invisibly in the background of the apps you're already using every single day.
This brings us to a fascinating shift in how we interact with software. Agentic apps. The industry buzzword for the past year has been generative AI, typing a prompt into a chatbot and asking it to write a poem or generate a picture.
But Apple is heavily leaning into agentic AI.
The distinction is critical. Generative AI creates new media. Agentic AI acts as an autonomous agent on your behalf.
Think of it not as a chatbot, but as a highly advanced macros engine that runs invisible strings through the user interface of your apps.
It understands the architecture of the software and can physically simulate finger tabs, navigate menus, and complete complex multi-step tasks without you having to manually guide it.
Let's start with how this transforms Safari, because we all suffer from catastrophic tab clutter. You're researching a vacation, and suddenly you have 40 tabs open spanning hotels, flights, and restaurants.
Safari now uses Apple Intelligence to automatically tame this chaos. It actively analyzes the text and context of every open page, identifies thematic similarities, and automatically groups related tabs together into distinct topics.
And it keeps doing this actively as you browse. When you are finally done booking the trip, you can close the entire San Francisco vacation topic with one tap, or save it as a permanent tab group for later.
They also introduced a highly utilitarian feature called Notify Me in Safari. Imagine you are desperately waiting for a highly competitive summer camp sign-up portal to open, or trying to buy a concert ticket the second a queue unlocks.
Instead of frantically refreshing the page every 10 seconds, you can use natural language to tell Safari exactly what you are looking for.
You close the tab, put your phone in your pocket, and Safari's agentic AI continuously monitors the underlying code of that specific web page on your behalf, pinging you with a high-priority notification the absolute millisecond it detects the change you requested.
And then there is Describe an Extension. If you are on a recipe blog and you wish there was a button to quickly extract just the ingredients, save them to your notes, and rate the recipe, you can literally type that desire in natural language into a prompt box.
Safari uses its cloud-based reasoning models to custom write the code and dynamically build a bespoke web extension just for you on the fly. But the absolute most impressive demonstration of agentic capabilities was inside the Passwords app.
We all know that password hygiene is terrible. The Passwords app already does a good job of warning you if you have a weak, reused, or compromised password that was leaked in a data breach.
But actually fixing those passwords is an excruciating process. It usually requires manually navigating to each individual website, trying to remember where they hid the security settings in their specific menu tree, generating a new complex password, pasting it in, saving it, and updating your keychain.
It's so tedious that most people just ignore the warnings.
Not anymore. Now, when the Passwords app flags a compromised account, you just tap a single fix button.
The app uses agentic AI to securely open a background instance of Safari, navigate to the specific website on your behalf, automatically sign in using your existing credentials, parse the document object model, the DOM, of the website to locate the obscure password reset fields, generate a cryptographically strong new password, inject it into the fields, submit the form, and seamlessly update your local keychain.
It's like having a highly trained cybersecurity specialist who goes around to all the sketchy, poorly designed neighborhoods of the internet and changes your locks for you while you just sit back and watch a progress bar.
This is the purest definition of everyday magic. It takes a high-friction, critical security task that users actively avoid and reduces it to a single, effortless tap.
And this deep agentic intelligence extends into how we communicate and organize our lives. In Messages and Mail, Apple Intelligence constantly analyzes the semantic context of your ongoing conversations and offers highly accurate, one-tap suggestions.
If a friend texts you asking, "Can you send me the photos from the barbecue this weekend?" Yeah, the Messages app recognizes the keywords, cross-references the location data and facial recognition of the people in the chat, and instantaneously surfaces a curated carousel of the best photos from that specific event right above your keyboard, ready to send with one tap.
Mail gives you intelligent suggestions to take action with favorite apps, even third-party ones. And the new writing tools are integrated deeply at the system level, available everywhere you can type text.
Siri can obviously draft an email from scratch based on a simple prompt, but it goes much further than basic text generation. It actively adopts your personal tone based on who you are communicating with.
If your historical email data shows that you usually send your manager quick, highly direct bullet points, Apple Intelligence knows that. If you ask it to draft an update, that is exactly how it will format the text.
It also provides system-wide automatic proofreading that runs silently in the background, subtly fixing grammar and structural issues without you ever having to explicitly ask for it.
The Calendar app gets a massive functional upgrade through natural language parsing. You no longer have to tap through tedious individual fields for the date, time, location, and attendees to create an event.
The keynote showed a user casually typing, "Elena and Magic Donuts next Tuesday at 2." As they typed, the agentic AI instantly identified Elena from the contacts database, cross-referenced maps to set the specific Magic Donuts shop as the location, calculated the date for next Tuesday, and populated the entire calendar block.
If a week later you need to change a recurring team lunch to every other week, you don't have to navigate a complex menu of repeating rules. You just type a sentence describing the change, and the calendar's underlying logic adjusts the frequency.
The phone app also gets a brilliant, highly practical feature called Call Context. When you initiate a call to a business, the app proactively searches your device to surface relevant information right on the call screen.
So if you are calling Delta Airlines to change your flight, before the customer service agent even picks up the phone app has already found your flight confirmation email from 3 weeks ago
Yeah.
and prominently displays your 6-digit flight code on the screen.
And importantly, to maintain privacy, this runs entirely on device, looking solely at who you are calling, not actively listening to what you are saying on the line.
This same philosophy of using AI to simplify complex multi-step tasks is applied to the Shortcuts app. Shortcuts have always been incredibly powerful for automating routines, but creating them has historically required a steep, almost programmer-like learning curve with complex conditional logic.
Now, you can just describe the automation you want in plain English.
The example they gave was fantastic. A user types, "When I'm leaving work, message Pedro, I'm on my way with my ETA."
Apple Intelligence reasons over that sentence and instantly builds the entire complex automation tree. It links the geolocation trigger for leaving the physical boundaries of the office, uses the Maps API to calculate the live traffic ETA to home, and slots that dynamic data into an iMessage addressed to Pedro.
If you later decide you want to add a step, and play my favorite tech podcast, you just tell it, and the shortcut updates the logic flow automatically.
The Home app also becomes significantly smarter through this agentic capability. If you have a smart home setup and you get a flood of individual notifications from various accessories, a door unlocking, a light turning on, a motion sensor triggering, the Home app synthesizes all of that data into a single, cohesive, updating activity thread.
For security cameras, Apple Intelligence actively analyzes the recorded video clips locally and generates accurate text descriptions of what happened in the frame.
This enables semantic search across all your security footage. You can literally search for the exact moment a package was delivered. Because the AI inherently understands what happened in the video through its generated metadata, it can comb through terabytes of footage, pull up the relevant clips across multiple 4K cameras, and seamlessly stitch them together to give you a complete multi-angle picture of what happened in your driveway.
Having an AI agent that organizes your life, secures your passwords, manages your schedule, and monitors your home security is undeniably helpful. But the most profound and perhaps philosophically mind-bending application of Apple Intelligence in these sources isn't about organization.
It is about how this technology is going to fundamentally alter our digital memories.
Okay, buckle up, because this is where the underlying tech gets incredibly advanced and the philosophical implications get very deep.
We are talking about generative AI in the Photos app and the brand new Image Playground. Image Playground is an entirely new system-wide experience built into the core of OS 27.
Relying heavily on the private cloud compute architecture to handle the massive processing load, Image Playground allows users to generate high-quality images from scratch in almost any artistic style, including highly photorealistic renderings, which represents a major upgrade over previous iterations of mobile image generation.
You describe what you want in natural language, and the diffusion models create it, but the real power is how it deeply integrates with your existing personal photos.
Right. You can take a photo of a friend from your massive library and type a prompt to generate a fun composite image of them standing next to a giant birthday cake.
And the editing process is entirely multimodal. You use both touch and text. You just draw a rough circle over the cake with your finger, type adlit candles, and the AI seamlessly generates photorealistic candles onto the frosting, matching the lighting and shadows of the original scene.
You can generate these images for messages backgrounds, custom contact posters, or unique lock screen wallpapers, and it all happens securely without Apple ever seeing your photos.
That is generating entirely new content. But what Apple is doing to your existing historical photographs in the Photos app is far more significant. Apple has always maintained a deep institutional respect for the craft of photography, and their stated goal here is to use AI to enhance images in ways that respect and elevate the original moment rather than just turning them into cartoons.
They introduced three major generative tools built directly into the Photos Edit suite. First is an aggressively upgraded cleanup tool. This uses realistic generative infill to seamlessly remove distracting elements, like a random person walking through the background of your shot, even against highly complex patterned backgrounds.
Second is the Extend tool. We've all taken a photo where we zoomed in too close, the framing is suffocating, or the horizon is crooked. You can use Extend to literally uncrop the photo.
The AI utilizes outpainting techniques to hallucinate the missing scenery beyond the original frame, giving your subject more breathing room without losing a single pixel of the actual captured image.
Both of those are powerful applications of in-painting and out-painting. But the third tool is the one that crosses a fundamental threshold. It is the one that changes the very nature of what a photograph is. It's called spatial reframing.
Yes, this goes back to the scenario we talked about at the very beginning of the deep dive. This was the most mind-blowing feature of the entire WWDC keynote for me.
You take a picture of your kids and you realize later you framed it poorly, or the camera angle was just a little too high, or you just barely missed making eye contact with them by a fraction of a second. Spatial reframing lets you grab the perspective of the photo and twist it after the picture is already saved to your camera roll.
Let's break down the mechanics of the technology here, because it's an absolute marvel of modern computing. When you select reframe on a 2D photo, you can touch the screen and physically drag the image.
As you do, the actual perspective of the entire scene shifts, exactly as if you had magically repositioned the physical camera lens in that exact moment in the past.
It achieves this by using highly advanced on-device spatial models, technology directly derived from the Apple Vision Pro's ability to map 3D rooms. The software analyzes the flat 2D photo, infers the precise 3D depth map of the scene, maps the pixels onto that invisible 3D mesh, and allows you to move the virtual camera through that space.
So you drag your finger down to get a better lower angle of the kids. As you do that, the edges of the photo naturally begin to blur and tear because you are asking the software to look at empty space that the camera never actually captured light from.
Once you find the perfect angle and let go of the screen, the system packages that data, sends it through the secure proxy tunnel to the private cloud compute servers, and the massive generative models instantly fill in those blurred edges, generating entirely new background content, the missing parts of the wall, the floorboard, the edge of the table, that seamlessly matches the lighting and texture of the original scene.
The presenter demonstrated this vividly. They showed a slightly awkward photo of two children looking slightly off camera. By dragging the perspective down and slightly over, the virtual camera lens was now aligned with their gaze.
The kids were now perfectly framed, looking right down the barrel of the new lens, and the extensive background that the AI had to hallucinate to fill the gaps looked completely, flawlessly natural.
Taking a step back from the tech, we have to look at the broader implication here. If you take a flawed, genuine photo, and you use a spatial algorithm to shift the angle of reality, and then a massive server farm hallucinates the missing pieces of the room, is it still a photograph?
This forces us into a deep philosophical debate about the definition of memory and digital truth. Is this modified file a photograph of a real moment that actually happened in physical space? Or is it an idealized, algorithmic recreation of a moment you wish it happened?
Apple's tools are now powerful enough to allow anyone to seamlessly rewrite their visual history to be aesthetically perfect. It's an undeniably incredible engineering tool, but it shifts the medium of photography from being a strict documentary record of light hitting a sensor to being an artistic, malleable rendering of reality.
We are crossing a major threshold here,
Oh.
enabled entirely by private cloud compute and spatial mapping.
It is wild to think about. It genuinely makes you wonder how we will look back at these perfect, flawless, AI-altered family albums in 20 years. Will we miss the messy, imperfect reality? Okay, let's pull back from the existential matrix and look at the broader picture. Because WWDC is massive, it's a developer conference, and there were a ton of vital ecosystem updates and major geopolitical rollout realities we need to cover to get the full picture.
Absolutely. Beyond the headline AI features, there were highly meaningful updates across the broader hardware ecosystem. In the Health app, Apple added robust cycle tracking support, specifically designed for perimenopause and menopause.
Users can meticulously log related symptoms like chronic fatigue, sleep disruption, or hot flashes, and the app's underlying algorithms will actively notify them when their cycle patterns suggest they are entering perimenopause, providing curated educational medical information to help them facilitate informed conversations with their doctors.
It's a vital, deeply necessary health feature for a massive demographic that has historically been entirely overlooked in Silicon Valley tech development.
Over in the audio world, the entire AirPods lineup is getting custom EQ, so audiophiles can deeply personalize their sound profile across all frequencies. And the new AirPods Pro 3 are getting expanded Apple Gym Kit functionality, leveraging new biometric sensors to allow users to sync their heart rate data dynamically through their iPhone directly to compatible gym equipment while they work out.
Visually, Apple Maps is significantly enhancing its flyover experience by combining its vast database of high-resolution aerial imagery with new vision intelligence models. The rendering of major cities is stunning. You can see hyper-realistic architectural details, the accurate shapes of individual trees based on their species, and real-time simulations of how sunlight reflects off specific glass skyscrapers at different times of the day.
And on the Vision Pro, you can now take standard flat panoramic photos you've shot on your iPhone over the years and use spatial algorithms to wrap them around you, turning them into fully immersive 3D spatial environments.
We also have to spend time on the developer tools, because without third-party developers adopting these frameworks, all of this AI potential sits idle. Apple is handing them some incredibly powerful new tools.
With the introduction of App Intents, developers can finally integrate the agentic capabilities of Apple Intelligence right into the core architecture of their apps. The keynote showed a highly complex scheduling app structured. A user just asks Siri to create an event for the marketing sync, and Siri uses the App Intents API to reach into structured, navigate its custom interface, and instantly add the event to the app's proprietary timeline without the user ever opening the app.
That is the mechanism that allows Siri to be useful everywhere. They also released the Core AI framework, which is a massive leap forward. It allows developers to run their own custom, proprietary machine learning models locally on the device, fully utilizing the power of the Apple Silicon Neural Engine without having to build the infrastructure themselves.
And inside Xcode, the software where developers write code, they introduced robust agentic coding assistance. The AI can analyze an entire app's code base and automatically localize it into 20 different languages. It can autonomously interact with simulated devices to test UI flows. And crucially, developers can even choose which foundational AI model they want the coding assistant to use, openly supporting Google Gemini right inside Apple's own development environment.
They also launched something called the Xcode Device Hub. For years, developers have struggled to test complex multi-touch gestures on computer screens. Device Hub brings heavily simulated cloud-based devices and physical test devices into one unified interface, where developers can use AI to simulate incredibly complex multi-finger, multi-touch controls, like a specific pinch, rotate, and swipe motion, to test their apps dynamically without needing 20 physical iPads on their desk.
It was a very strong showing for developer quality of life improvements. There was even a lighthearted moment where Craig Federighi demonstrated an app called Daydream. It uses the on-device core AI models to identify the specific clothes in his closet and recommend outfits that stay strictly within what he joked was his extremely narrow blue shirt fashion comfort zone.
It was a funny bit, but it perfectly demonstrated how quickly a small third-party app can deploy powerful local image recognition natively.
But transitioning from the shiny features and the developer tools to the cold reality of the actual rollout, We need to look closely at the fine print in the press release, because there are major caveats. All of these software features will be available as a free update this fall, with developer betas available today and a public beta launching next month.
But there are strict hardware limitations for the AI. To actually use Apple Intelligence and the new Siri AI, you must have an iPhone 15 Pro, an iPhone 15 Pro Max, or the upcoming iPhone 16 lineup. For iPads and Macs, you are required to have an M1 chip or later.
That restriction comes down entirely to silicon architecture and RAM. Large language models require an immense amount of active memory to process tokens efficiently. The A17 Pro chip in the iPhone 15 Pro and the M-series chips in the Macs have the specific neural engine cores and the unified memory bandwidth necessary to run these foundation models locally without grinding the device to a halt. Older hardware simply cannot physically accommodate the models.
And there are also strict usage limitations we need to talk about. Apple's press release explicitly noted that some of the most intensive features, specifically the generative image capabilities in Image Playground and the spatial background hallucination in photos, will have strict daily usage limits for free users.
This is because they require massive compute cycles from those highly secure private cloud compute server models, and server time is incredibly expensive. If you want increased daily access to those generative tools, you will need to subscribe to the paid tiers of iCloud Plus Stable, which also happens to unlock the Apple Intelligence semantic search support for multiple home security cameras.
But the hardware and the paywalls pale in comparison to the geographical limitations. This is where the story gets incredibly complex. Siri AI will launch strictly in US English to start, with localized versions for other languages rolling out aggressively over the next year.
However, buried in the regulatory filings and the press release is the fact that Siri AI and the entirety of the Apple Intelligence feature set will not be available initially in the European Union on iOS and iPadOS.
That is a massive portion of their global user base left entirely in the dark. Apple stated they are working with regulators to find a path forward, but they are clashing directly with the requirements of the Digital Markets Act, the DMA.
The DMA is designed to prevent tech monopolies by legally mandating interoperability and preventing companies from favoring their own services. But Apple's entire argument for the safety and privacy of Apple Intelligence is that it is deeply, inextricably integrated into the core OS, and that it relies on a proprietary closed-loop system like private cloud compute.
If the European Union mandates that Apple must open up those deep OS-level AI hooks to third-party competitors, say, allowing Meta's AI to have the same root access to your personal semantic index as Siri does, Apple argues that fundamentally breaks their cryptographic privacy promises. It is an immovable object meeting an unstoppable force.
Furthermore, in China, Siri AI and the other new Apple Intelligence generative features will completely disabled at launch. Apple is currently trying to work through a labyrinth of local regulatory requirements regarding data sovereignty and government approval of large language models.
When you zoom out, what Apple is really dealing with here is a fundamental shift in their corporate challenges. For 3 decades, Apple's primary adversary was the laws of physics. How do we make silicon chips smaller, faster, cooler, and more power efficient? They solved that.
Now, their biggest hurdles are entirely legal and geopolitical. Deploying system-wide agistic artificial intelligence to 1 billion users globally requires navigating a fractured, incredibly complex labyrinth of international regulations, data sovereignty laws, and competitive mandates.
It's a completely new era for them. They aren't just building phones anymore. They are deploying global cognitive infrastructure.
Okay, as we wrap up this massive deep dive, let's summarize the journey Apple just took us on. They didn't just announce a chatbot. They started by meticulously sweating the microscopic details of the OS foundation, speeding up the RAM paging for faster app launches, completely rewriting the network logic to fix Wi-Fi handoffs, and giving us granular, accessible design control over the liquid glass interface.
Then they systematically built a digital fortress around the family ecosystem. They moved far beyond basic parental controls. They integrated actual clinical research from the AAP right into the settings menu to provide objective screen time baselines. And they engineered complex cryptographic APIs to actively protect children from inappropriate content while maintaining absolute anonymity.
And only because that unshakable foundation and those massive safety walls were perfectly in place did they feel comfortable unleashing Apple Intelligence. It's a hybrid marvel of highly efficient on-device processing and the cryptographically secure private cloud compute architecture, augmented by a historic, almost unthinkable collaboration with Google Gemini.
We saw an agentic Siri AI that can finally hold a complex conversation, navigate the hidden menus of our apps for us, secure our passwords by actively browsing the web like a digital specialist, and completely reimagine our digital reality by letting us shift the spatial perspective of our most precious photographs.
It is, without a doubt, the most sweeping, comprehensive, and architecturally complex vision of how artificial intelligence should integrate into a consumer ecosystem, quietly acting in the background, secured by cryptographic math, and seamlessly blending into the tools we already use.
It really is a masterpiece of ecosystem design.
But before we sign off, I want to leave you, the listener, with a final thought to ponder. We started this deep dive talking about the magic show of a keynote versus the muddy waters of the complex plumbing underneath. And Apple has just offered us the ultimate digital plumbing to make our lives flawlessly clean and frictionless.
True.
But think deeply about this. If Apple Intelligence flawlessly curates your Safari tab so you never have to feel the friction of being overwhelmed, if it writes your daily emails perfectly in your exact voice so you never have to struggle for the right words, if it automatically navigates the web to update your passwords without you ever looking at the screen, and if it perfectly algorithmically reframes your slightly flawed family photos so everyone is looking at the camera with perfect lighting and perfect posture, at what point are we experiencing a digital life curated more by the soothing perfection of Apple's algorithms than by our own messy, frustrating, beautiful human reality?
That tension between convenience and authenticity is the ultimate question of this new era.
Thank you so much for joining us on this deep dive. We'll see you next time.